Hi, welcome to 2D motion, vectors and direction. We are simply just going to understand what vectors are here. And anytime you hear the word vector, we're thinking about these arrows. These arrows can be placed in any which direction to make it understandable by us humans what is happening. And we're communicating exact physics of what's occurring with certain objects. Okay. So we're really looking at arrows, a lot of arrows, nonstop arrows. So you want to think about this in a very black and white sense. We need to think about scale. What does that mean? So the scale of the arrow is actually important. So if I have, let's erase this one. If I have an arrow that's about like this. And then I have an opposing arrow that's about like this. Which arrow is bigger? And let's just look at that. Okay, well, clearly the arrow pointing to the right, and we'll actually now put a direction here, kind of skipping ahead. But I could just say, we'll just say, well, pointing it to the right is bigger. And the one going left is clearly smaller. Okay, so that's scale. All right. And what if we had an arrow pointing down? Okay. Now the size of the arrowhead shouldn't matter. Okay. So even though I have different sized arrowheads, that doesn't matter. It's the length of that arrow that matters. Okay. So clearly the one going right is the largest. Now the vector arrow. Okay. We need to have this arrow be specific. It can't just be a line. All right. That is how we communicate the vector arrow. Now for the direction. Okay. Typically, something is listed on whatever data you're looking at. It could be a compass like thing, it could be, however they want to list it. It could even be listed as a graph. Okay. And the arrow could be, let's say, going like this. And this angle, there could be an angle here. Okay. And this would be approximately 45 degrees. And if this were a compass, north, east, south, west, well, this would be going 45 degrees north of east. Okay. So, why is this important? Because it gives exact direction or exact forces as to what's occurring. All right. So, if this is 45 degrees north of east, okay, then something like, and I'll have to draw the line a little underneath it, this dotted line that I'm drawing, this arrow here, would be just east, okay? And we can say that this is the 0 degree mark. So 0 degrees east would be this arrow, this dotted arrow here. Um, what we don't have is a scale. Okay, so let's add a scale here. We can say that for every inch, let's say this is 1 inch. Okay, for every inch. So say this is an inch, and so that's 1 inch. There's 2 inches, and we'll delete this tail going down here. So for every inch, all right, there's a certain value to that. Okay, so this inch could actually mean 10 meters. It could mean whatever the producer of this data wants it to be. So it could mean 10 miles. We could be scaling, if you put the whole world on a map, and here's my Pangea of all the lands combined, and I made a vector, let's say this is my inch, or let's just have a vector rather than an actual scale. Okay. This clearly, even though this is 1 inch on screen, that if on our planet, that 1 inch can't equal 10 meters. It can't equal 10 meters. That 1 inch is clearly something far more. Okay. Hundreds of miles that 1 inch is encompassing for that. So that's scale. We have our vector arrow, we have direction. Okay. So that's just something that you need to have in your brain mind socket. Okay. These arrows are indicative of most of what you may use in the future for your engineering. All right. I will see you next time.